probably don't need your graphic organizers out. If you have them out, that's fine. But today and tomorrow are systems of equations and inequalities that could involve conic sections. So you have solved systems of equations before. We are using those same methods, but because you have equations that could be conic sections, there's a little bit more to the process, or things could work out just a little bit differently. We are starting out, there's 2 examples I have, or actually 3 examples that we have to go through the lesson. And the first one is if you have a system of equations where one equation is a linear equation and then the other equation would be a quadratic equation, so it could be one of your conic sections. So it does say at the top of that front side that when you have a system of equations that consists of a linear and a nonlinear equation, your system could have 0, 1, or 2 solutions, and it does give some possibilities just looking at it graphically there for you. We are not solving these by graphing. We are solving them algebraically, but it just shows that when you have a line and a conic section, or even this one here is an absolute value graph, your line could not intersect the conic section. They could intersect at one point, or they could intersect twice. So 0, 1, or 2 solutions would be your options. And so the algebraic methods, I know I had referenced this yesterday as well. You could use substitution or elimination, or a combination. And I will say between the examples, if you have a linear quadratic system, as with example 1, so one equation is linear, one is quadratic, you'll probably be using a combination of these methods. Versus quadratic systems, you may only need one of the 2 methods. So we're going to look at example 1 together. We have the following system of equations. 3 times the quantity y minus 4 minus 2 times the quantity x minus 3 equals negative 6, and then 5x squared plus 2y squared minus 53 equals 0. And I'm going to write down for this example as well, there's kind of 3 big major steps. Within that, there's different steps, but 3 main steps you want to focus on to solve a linear quadratic system. So step 1 would be to solve the linear equation for either x or y. So solve the linear equation for one of the 2 variables. Get x or y alone for one of the 2. And so that means you do have to identify in your system of equations which one of the 2 equations is the linear equation. Anyone have an idea here, equation 1 or equation 2, which one is the linear equation? Equation 1, how do you know that one's linear, not the second one? Yes. So the linear equation will have, or rather if you want to just make a note here, the exponents on the variables are 1. Or rather, you can see an equation to a quadratic equation is when you have an exponent on a variable of 2, and we have both an x squared and a y squared. So identify which equation is linear. We'll solve that equation for either x or y. It doesn't really matter which variable you solve for, whichever one is the easiest to solve for, I would say. So I'm just going to rewrite that top equation below here. And then we'll work on solving that. We'll talk about whether or not x or y, which one is a better variable to solve for. Before I solve this, or as I start to solve this equation for x or y, though, what am I going to have to do first? If you want to solve for x or y? We should do x.
I think it looks easier, but I'm not sure.
Okay. But even if you want to solve for x or y at this point, what do we have to do first? Or, yeah, distribute, I heard. We need to simplify that left side. So for the y minus 4, distribute that 3. So 3y minus 12. And then make sure when you are distributing for the x minus 3, because it's minus 2, distribute the negative with the 2. So we have minus 2x, and then it becomes plus 6. We still have equals negative 6 on the other side. Okay, from here, I'm still going to simplify that left side, the minus 12 plus 6. I can combine those constants. So I have 3y. I'll write the minus 2x next, and then the minus 12 plus 6 would be a minus 6 equals negative 6. And if I'm looking to get either x or y alone, I would want to move that constant, that minus 6, to the other side. So if I add 6 to each side, I'll have 3y minus 2x equals, and actually it cancels out on each side, so I have equals 0. Having 0 on one side is okay. You know, sometimes it makes you think it's wrong if you have 0 on one side. And then I want x and y on opposite sides if I'm trying to solve for one of them. So just to keep everything positive, I personally would add 2x to each side. So 3y is equal to 2x. And so here's where you have to make the decision of which one is going to be easier for you. Because to solve for y, we'd have to divide both sides by 3. To solve for x, we have to divide both sides by 2. Anyone have an idea of which number you'd rather divide by? Divide by 3 or divide by 2? I heard both. Anybody have a reason to back up what you said? Yes, if you divide by 3, so if I solve for y and I divide by 3, I'm going to have 2/3 x. You will have to keep that as a fraction. Because 2/3 would be 0.6 repeating. You wouldn't be able to change it to a decimal, and you'd be working with the fraction 2/3 in the next step. Versus if you divide by 2, 3 over 2, you could keep as a fraction, but if you divide 3 by 2, you get 1.5, and then you could write the decimal, and that might make it a little bit easier. So again, it doesn't matter which one you solve for. If I solve for y and had 2/3 x, that's fine. As long as my math is correct, I'm still going to get the right answer. But make it easier on yourself. You have the choice of what to solve for, reason which one is going to make the steps a little bit simpler later on. So I'm going to write the decimal. So 3 divided by 2, I'll have 1.5y equals x. Okay, so this equation, just based on how it was given to us, there were a lot of steps to get a variable by itself. Depending on the system you start with, maybe you already have a variable by itself for your linear equation. If not, get a variable by itself for the linear equation. Step 2 then, I'm going to include that over here. So think to substitution with just linear equations, where both equations are linear. Once I have this equation by itself, I can then substitute that into the other equation for x. Make sure you do keep that exponent of 2. So I'll put here, if you want to write out the steps in words so you understand what you're doing, you're going to substitute the equation from, I'll put from 1, from step 1, into the quadratic equation. And then I'll write that out here. So I'm going to rewrite the quadratic equation with replacing the x in that equation, since I solved for x, replacing the x in that equation with 1.5y. So I'll have 5 times, in parentheses, 1.5y squared. So make sure that's all in parentheses there. And then I still have the plus 2y squared minus 53 equals 0. And here, a way to know if you're substituting correctly, I know we talked about this with linear systems as well, Notice in the equation now, every variable I have is y. So if you still have both variables, if you still have x's and y's in your equation, then the substitution was not correct. You're trying to get one variable so that we can solve for it. In this case, now we can solve for y. If I want to solve this equation for y, what would have to be done first? Solving this for y, what would we have to do? All right, actually what I'd like you to do then in your groups, talk about what you would do, solve this equation for y. I'll have you do this step. There's a step after it, at least do this step. Get this equation solved for y. Talk about how you would do it, work through it. We'll go through, make sure we're all able to do that and get the correct values for y. And I'll walk around in a moment if you have questions or your group has questions.
Oh.
This would also be y squared, right? Yep, so then we can just start that. Yep. Yep. Well, get the y squared in. Yep. That's the R2. So you have the 2 again. Not yet. Eventually, like once you get y squared, it's a lot. Because it's so that's the whole summer word.
Yeah. Oh,
Okay. Here, the 1.5 also has to be that product of these squared.
well, that's what I said.
I think you just multiply 5. I feel like I don't know what to do. Well, here you left off the y squared. Because that 52 is over these two.
Well,
So you have to do 1.5 squared first, and then multiply by 5.
that's what I did, but then I was like, but why is it going to be by itself then? Now I don't know. Well, yeah, I know.
Because otherwise everything else was right. It's just the 9.5.
But I just thought, well, if you do that, and then you don't square.
Okay, I that makes sense.
Yeah.
Okay, I know some of you are at some different spots, but we're all on the right track. So here, remember, it's possible you're going to get multiple solutions. Some of you I know had gone on and already started the last step. Positive or negative 2 would be the y value. So there are 2 different y values. So don't forget in these problems when you take the square root of a number, you get a positive and a negative. And I know some of you are going to need to get caught up with this. That's fine. I'm going to get you started on step 3. Remember, when you solve a system, you are solving for both variables. We don't just want y, we also want x. So since you now have 2 y values, you can go back and you're going to have to substitute both of these in. So you really have y equals positive 2 and y equals negative 2. You're going to have to substitute these both back in to one of your equations to get the corresponding x values. Now, you could go back to one of your original equations and do that, or from step 1, you have this equation right here. That would be pretty simple for you to substitute your y values in to get x. Okay, so step 3, I'll just make a note here, is to substitute your value or values. In this case, we do have more than one, but substitute your values from step 2 into equation to solve for the other variable. In this case, it's x, but maybe in a different example, you found x instead first, and now you're trying to find y. Okay, so I'm going to choose to substitute it back into this equation here, just because I already solved this one for x. You could go back to the very beginning, one of those 2 equations as well. So as I substitute this in, I have to plug in 2 separate y values. So if y is positive 2, I substitute that in here, and I would get x equals 1.5 times positive 2, and therefore x would be positive 3. Now, also remember with systems of equations, how did we write the solutions? What form did we write the solutions in? Anyone remember? Okay, your solutions are representing where the 2 graphs intersect. They're intersecting at ordered pairs. So your answers should be written as ordered pairs. So since when y is positive 2, x is positive 3, that's the ordered pair 3, 2. And then when x is negative 2, if I substitute that in, or when y is negative 2, x is 1.5 times negative 2, so x is negative 3. So my second solution, the second place they intersect, is at negative 3, negative 2. So rather than writing your solution as x is plus or minus 3, y is plus or minus 2, write the ordered pairs, which x value is paired with which y value. Okay, any questions on that one? I'll leave this up here for a moment. I know some of you were getting caught up from step 2.
I think one was to find g of x is equal to the integral of fx, evaluated from 1 to x. So it's only going to be the integral from this point on, because that's where it's evaluated.
Well, that's how it's evaluated, yes, if you're finding values. The graph is still, you're still working with the graph, because you could go backwards. Like you could
X
go
could be
from
negative.
Yes. Mm-hmm.
All right. So
this is just how it's defined, but you still have the full
so
interval
that
for the
wouldn't,
graph.
I guess that wouldn't change this answer right here, because I'm still just from here to here, or if it was negative, it would be from here to here. That's just where it's defined from this side.
Yep.
1.
Mm-hmm.
So then.
So if you were actually finding a value of g,
yeah,
this is what the starting point would be 1.
But B and C aren't finding values of g,
Right.
so that's not going to be the same.
Right.
Thanks.
Mm-hmm. All right, am I okay to move this? I know some of you are still writing some things down. Okay. Examples 2 and 3. And between these examples, some things work out a little bit differently. These are quadratic systems, so neither of your two equations is linear. They are both quadratic equations. So this just shows some graphical representations of systems involving two conic sections. You can have anywhere from 0 solutions to 4 solutions. So here's an example of a parabola and a hyperbola that never intersect, so there's no solutions. A parabola and a circle, they could only intersect once. It shows again they could intersect 3 times. Here's a parabola and ellipse is intersecting twice. This could be a circle and an ellipse, or 2 ellipses intersecting 4. So it is possible that you're going to get 4 solutions. Okay? So it does say, though, if both of your equations are quadratic, elimination does work. So it's not that you can't use substitution, you still can, but you can start out using the elimination process. If I go back and just take a look at example 1, notice elimination doesn't work for this system because you have y and y squared, x and x squared, so there's no way to eliminate your variables. X and x squared are different. They can't eliminate each other. Y and y squared can't eliminate each other. However, if you have 2x squareds or 2y squareds, those can be eliminated. So this is why with quadratic systems, elimination does work. So if we look at example 2, if we wanted to use elimination for this one, elimination, remember you're trying to eliminate a variable. What would I have to do in order to get either my x squared or my y squareds to eliminate? For example 2. Yes, you need either the same or opposites, like one positive, one negative coefficients in order to get them to eliminate. So by looking at this, if I just take a look at the y squareds, really you could eliminate either one. I'm looking at the y squareds because one's already positive, one's negative. How would I get these to be able to be eliminated? Yet multiply this bottom equation by 4. Remember, you have to multiply everything in the equation. So I'm just going to rewrite this here. I'm going to rewrite the top equation. And then the bottom equation would become 8x squared minus 4y squared equals negative 4. And then you have to think about what do you have to do to get them to be eliminated. So because I do have opposite coefficients, one's positive, one's negative, they're eliminated or they equal 0 if I add them together. So if I add the two equations together, the 4y squareds, or the 4y squared minus 4y squared will cancel out. And then I would add the resulting like term so I can solve for x. So I would have 3x squared plus 8x squared, that's 11x squared, equals 48 plus negative 4 is 44. Solve for x squared. So I want to divide both sides by 11 before I take the square root. So x squared equals 44 divided by 11 is 4. And then I can take the square root of each side. And again, remember when you take the square root, you do have two answers. X would be plus or minus 2. So I have a positive 2 for x, and I have a negative 2 for x. Okay, then once you have that, you can go back to one of your two original equations in order to solve for y, but you're going to have to substitute in the two x values separately. So I'm just going to choose, it doesn't really matter here. I'll choose this bottom equation to substitute them into, and I'll substitute in positive 2 first. So if I substitute in positive 2 for x into the bottom equation, I'll have 2 times 2 squared minus y squared equals negative 1. And then I would solve for y. So careful here, you do need to evaluate the exponent before you multiply. So I'd have to do the 2 squared first, which is 4, times 2 is 8. If you did it the other way around, you'd have 16, and that's not right. So 8 minus y squared equals negative 1. I would then subtract 8 from both sides. Make sure you keep the negative in front of the y squared, so negative y squared equals negative 9. If both sides are negative, I can really just divide or multiply each side by negative 1 to make both sides positive, so y squared equals positive 9. Meaning if I take the square root of each side, again, I have two answers. When I take the square root, I have plus or minus 3. Okay, so this really means I have two different ordered pairs just for this one x value. So when I'm listing my solutions, I'll list them up here. One of my solutions is the x-coordinate positive 2 and the y-coordinate positive 3. Another solution is the x-coordinate positive 2 and the y-coordinate negative 3. So I have two ordered pairs for that one x value. I still have a second x value to plug in. Okay, so I also need to substitute in negative 2 for x. So I'll substitute into the same equation. So I have 2 times negative 2 squared minus y squared equals negative 1. Now, negative 2 squared is also positive 4 times 2 is 8. Okay, I hear kind of some whispers going on. You might realize this already. Notice these are the exact same. So if I substitute in positive 2 or negative 2, this equation is going to come out the same as the previous one. So I could go through all the steps again. If you realize it is the exact same, I can just say, okay, the solutions are going to be positive and negative 3 for the y. Okay, same thing. So that means I have two more ordered pairs. So when x is negative 2, I have a positive 3 for y. But when x is negative 2, I also have a negative 3 for y. So altogether, this system has 4 answers. Okay, any questions on that one? Okay, now example 3 is also a quadratic system. It does work out differently than example 2, which is why I included 2 of these ones. But Corey, you have a question? It does not, no. I just chose the bottom one. I could have used the top. Okay, so for example 3, notice again, because both equations are quadratic, I could start out using elimination. If I look at the x squareds, I already have 1x squared and 1x squared. So I could start out right away and say to cancel these out, I could just subtract the bottom equation to get them to cancel, because x squared minus x squared would cancel out. You could also multiply one of your equations by a -1 and then add the equations together. That part's up to you. I know some of you will just subtract, some of you will multiply. I'm going to show the subtracting, because when you subtract, you want to make sure you're subtracting everything. Okay, so x squared minus x squared cancels out. Now, notice I have a y squared and then I have a 3y. These are not like terms. So when I write out my left side here, I'm going to write it as I still have the y squared from that top equation, and then I do have the minus because it's being subtracted, so y squared minus the 3y. I can't combine them, they're not like terms. Equals, on the right side though, 8 minus 10, those are like terms. I can do 8 minus 10, that's -2. Okay, so by subtracting the two equations, x squared eliminated, this is the equation I'm left with to solve for y. The question is, how do I solve this for y? So what type of equation is this? It is quadratic. I could write it as a trinomial. I could add 2 to both sides. So y squared minus 3y plus 2 equals 0. How would I solve this then for y? You could complete the square. If you complete the square, you would have wanted to leave it like this, but you could complete the square. Or what are the other two methods we have? You could graph it. Okay, what are the other two methods I'm thinking of? Factor, or a quadratic equation can be solved using the quadratic formula, yes. So you could factor this or use quadratic formula. If it factors, that's usually quicker than quadratic formula. I'm going to see if it factors. So we'd be multiplying to 2 and adding to -3. Are there two numbers that work? Yeah, -1 and -2. Multiply to +2, add to -3. And then because there's a 1 in front of the y squared, so I can factor this to y minus 1 times y minus 2 equals 0. And then because I factored it, set both factors equal to 0, so y minus 1 equals 0, or y minus 2 equals 0. Solve each for y. The first one, add 1 to both sides, so y equals 1. Or the second one, add 2 to both sides, y equals 2. So I have two answers for y. I then have to substitute both of these back into one of my two equations to solve for x. It doesn't matter which one you substitute it into. I'm going to choose the second one again just because then I'm just substituting in y. I don't have to square anything, but it's up to you, whatever you want to do. So I'm going to substitute in y equals 1 first into that bottom equation. So I have x squared plus 3 times 1 equals 10. So that's really x squared plus 3 equals 10. If I subtract 3 from both sides, x squared equals 7. And then I can take the square root. Now I want you to leave your answers in exact form, so don't give decimal approximations. I cannot take the square root of 7. So leave this. This is really x equals plus or minus the square root of 7. I would just leave it. It can't be simplified. It's not a perfect square. So I have positive root 7 and negative root 7. So that means, so far I have two solutions. because with the y value 1, I had 2 x values. So make sure also you're keeping your x and your y straight. So one of my ordered pairs would be positive square root of 7 with the y value 1. Another would be negative square root 7 with the y value 1. So those are 2 answers I have so far. Okay, and then I would do the same thing but with the y value 2. I'll write that over here. I'm going to substitute it into the same equation. So I have x squared plus 3 times 2 equals 10. 3 times 2 is 6. So x squared plus 6 equals 10. I can then subtract 6 from both sides. So x squared equals 4. Take the square root of each side. 4 is a perfect square, so I get plus or minus 2 for the x values. So that means this one also has 4 answers, so I have another 2 answers here. And again, keep your x's and y's straight. So I have the x value positive 2 with the y value 2. I also have the x value negative 2 with the y value 2. These are the 4 answers. So those 2 systems intersect, or those 2 equations intersect 4 times. Okay, any questions on that one?